Okay, so if you manage specialized mobile equipment, maybe it's a high-tech utility van or an off-grid setup, maybe even a fire truck, you've probably hit this technical wall. Modern tools, they demand serious battery power. But the standard 12-volt vehicle system, it just can't keep up. Think about it. You pull the truck back after a long call, plug it into shore power, and bam, suddenly all those tool batteries, the rescue saws, the extraction gear, they're all fighting the main truck batteries for juice. It's just, it's a bottleneck, especially in critical situations.
It really is. It creates a huge operational risk. And the weakness is, well, it's fundamental. Those standard 12-volt systems, they were often designed for like lighting low-draw stuff. They just don't have the capacity to convert power fast enough for multiple modern AC chargers. And that's exactly the problem we're digging into today. We're looking at the documentation for a heavy-duty power solution called the Kraken Charging Hub. We've got the tech specs, the B2B procurement, FAQs, the whole deal.
Right. So our mission for you, listening in, is kind of twofold. First, let's unpack the tech side. This thing boasts 3,000 watts continuous, 100 amp hour capacity, impressive numbers. But second, and this is just as crucial for anyone actually buying or managing these things, we need to look at the logistics. What are the real-world hoops you jump through? B2B pricing, international freight rules, lead times, getting a beast like the Kraken actually deployed.
Yeah, we want complete clarity. Not just the impressive specs, but how it actually solves that headache of keeping critical tools charged and ready, reliably.
Okay, let's start there then. Section 1, the problem itself, mobile power and how the Kraken steps in.
Well, the core innovation here is delivering continuous onboard AC power. It does this through an integrated inverter and its own lithium battery bank. Compare that to standard systems.
Yeah.
Normally, you only get decent tool charging when the truck's plugged into shore power, right? Which limits your window.
Right. And those shore power hookups might be short, maybe just a few hours between calls or shifts.
Exactly. The Kraken flips that script. It lets tool charging start instantly. The second you slot a dead battery into its charger, it's working. Doesn't matter if the truck's plugged in or not. The Kraken itself absorbs that big charging load, spreading the demand over time using its internal 100-amp battery.
Ah, I see the benefit immediately. So if you've got that 100-amp battery supporting 3,000 watts of AC, how many tool batteries can that realistically handle before the Kraken itself needs a full recharge? That 100-amp, that seems key.
It absolutely is key. Now, the exact number of cycles depends on the tool battery size, obviously. A 5A pack versus a 9A pack, for instance. But the 100-amp internal battery is definitely large enough to handle a lot of hydro charging while the truck is running, or even just sitting there for hours. It basically decouples the tool charging from the main vehicle system. So you can dedicate that limited shore power just to the truck's primary batteries. Meanwhile, the Kraken handles the demanding tool charging load.
Got it. Let's look at the specific model we studied, the CH3K 1050100.
All right, that one. It's a 3-kilowatt charging hub, built around that 12-volt, 100-amp-hour capacity. The brains of the operation, so to speak, is the Sinewave inverter charger, the KPBIC 123100 model. That's the component doing the heavy lifting, managing the power flow, keeping things stable, even with heavy industrial loads kicking in.
Okay, that sets the stage. But, the details matter. Let's really crack open these specs now and see where it earns that heavy-duty label. Section 2, decoding the technical specifications.
Yeah, the raw numbers are pretty impressive. We're talking 3,000 watts of continuous output power. And for those moments when things like heavy saws or industrial gear first kick on, they need a burst, right? A surge. The Kraken handles that with 6,000 watts of peak output.
6 kilowatts peak. That's substantial. What does that mean practically in, say, a rescue scenario or on a construction site? Is that kind of surge what keeps hydraulic pumps or big tools running smoothly without tripping?
Precisely. It's the difference between a tool maybe stalling under load or just powering through the job. But just as important is the quality of that power. The specs highlight a true sine wave output waveform. And crucially, less than 3% total harmonic distortion, THD.
Okay, for those of us not deep into electrical engineering, why is that 3% THD figure so critical? Does dirty power actually harm these expensive tool batteries?
Oh, absolutely it does. Think of THD as like noise or static on the electrical signal. If the power isn't a clean, true sine wave, if it's choppy or dirty, it creates extra heat and stress inside sensitive electronics. Modern lithium-ion batteries have these really sophisticated battery management system, BMS chips, right, for safe charging. You feed those chargers dirty power, and you risk overheating, you shorten the battery's lifespan, you get unreliable performance. So that low THD from the Kraken means clean power, protecting your investment.
That makes a lot of sense. Protects the expensive bits. And the efficiency is pretty high, too.
Yeah, peak efficiency is rated at 90%.
Yeah.
That's excellent for this kind of power conversion. Plus, it's flexible. The max charger current is 100 amps, which is a lot. But the installer can set it manually or automatically. There are options 5, 15, 35, 55, 75, or the full 100 amps.
Why wouldn't you just always crank it to the max 100 amps?
Well, operational flexibility again. Maybe the system is running off a smaller generator temporarily. Or maybe the main truck batteries are also really low and need priority. Being able to dial back the Kraken's draw lets the whole system keep working reliably without overloading a weak input source. It's about intelligent load management.
Okay. Let's move to storage and monitoring. The internal battery and solar readiness.
Right. The heart of the storage is that 100 amp lithium battery. Runs at 12.8 volts nominal. And for off-grid or continuous use, it integrates a WP SunTrack DUO MQSST current controller. That means it's solar ready. It can handle up to 500 watts of PV input power at 12 volts.
And MPPT, that's maximum power point tracking. That's not just a nice to have for solar, is it? It's pretty critical.
It's vital, yeah. An MPPT controller is constantly adjusting, optimizing the power it pulls from the solar panels. It makes sure that even if the light isn't great or it's really hot out, you're always squeezing the maximum possible charge out of those panels.
Yeah.
Without MPPT, you'd lose a fair chunk of potential energy.
And managing all this power flow, inputs and outputs, there's a smart shunt involved. Tell us about that.
Think of the smart shunt as the system's dashboard or mission control. It precisely tracks every bit of energy moving in and out. It monitors the supply voltage over a really wide range, 7 to 70 volts DC, which helps diagnose issues across different vehicle types. And crucially, it tracks input currents from negative 600 amps all the way to positive 600 amps. And it can track battery capacity from 10 up to 10,000.
Wow, why is that kind of precise two-way current tracking so valuable for, say, a fleet manager?
Because it enables predictive maintenance. It's not just checking voltage. It knows exactly how much capacity was used, how long recharge took. That level of detail helps flag potential problems, like early battery degradation or maybe system inefficiencies, before they cause a failure out in the field. That saves real money and downtime later on.
That makes sense. Which brings us neatly into Section 3, applications and integration. It's clear this isn't just for fire trucks.
Oh, absolutely not. The engineering here is all about robustness. It's built for any demanding use. Think industrial equipment charging, complex renewable energy systems, maybe remote research outposts, heavy-duty off-grid power. Basically anywhere you need reliable, clean AC power, and failure isn't an option.
And this is where integration becomes really relevant for anyone designing a system. If you've got existing infrastructure, the Kraken seems designed to play nice.
It is. It connects into standard 12-volt battery systems pretty easily. It works with different chemistries too. Lead acid, AGM, lithium-ion, as long as the capacity needs are met. And importantly, on the data side, it supports standard industrial protocols like CAN bus or Modbus.
Okay, explain the benefit of CAN bus or Modbus for the end user. What does that enable?
Well, it simplifies fleet management significantly. Instead of having someone physically check each unit, the Kraken can feed real-time data performance, efficiency, maintenance alerts directly into a larger system, like a vehicle control system or an industrial control system, an ICS. This means operators can monitor the health and charge status of all their units remotely. Streamlines operations, helps schedule maintenance proactively. It's about visibility.
Right, and for these kinds of critical applications, safety and reliability, they're non-negotiable. What protections are built in?
The safety features are comprehensive. You've got overcurrent protection, short circuit protection, precise voltage regulation to keep the output stable, and integrated surge protection. That shields everything from unexpected voltage spikes coming in from outside.
What about overload? If there's a sudden massive power draw that briefly goes over that 3000 W continuous rating.
It's designed to handle that dynamically. There's advanced circuitry constantly monitoring the load. If the system starts to strain, it automatically adjusts the power output, maybe drops the output slightly or adjusts the phase, whatever it takes to prevent overloading without just shutting down completely. Keeps things stable. And for long-term health, the manufacturer suggests periodic checks, maybe every 3 to 6 months, depending on how hard it's used. And it supports firmware updates, too, to keep performance optimal.
Fantastic. Okay, we've got a good handle on the tech and the operational side. Now let's pivot. Section 4, the logistical deep dive. For anyone in procurement, this is where the rubber meets the road. Can you actually get this unit deployed, specs aside?
Yeah, this part is critical. Procurement can often be where things stall. So PE Energy, the supplier here, they focus heavily on B2B, business-to-business, bulk pricing. It's a quoting process. And pricing, it's subject to market fluctuations. Think raw materials, so quotes, are typically only valid for 30 days once issued. You have to move relatively quickly.
And cost isn't just the unit price. You need to think about certifications too, right?
Absolutely. Some standard certifications might be included, but the docs make it clear. Specialized or region-specific certs might cost extra. Depends on the manufacturer, the rules where you are. That's definitely a line item to confirm up front. Avoids budget surprises later.
Okay, shipping. Costs vary, obviously weight, destination, but they mention customers can use their own freight accounts. FedEx, UPS, DHL, that seems like a plus for bigger companies.
It is, yeah, especially if they have good negotiated rates. But the rule for international orders is really important for anyone planning globally. Orders over $2,500 US. International customers must plan on hiring their own freight forwarder. To handle all the customs paperwork, duties, that complexity, that $2,500 mark is a key threshold.
And speaking of planning, let's hit lead times. Often the biggest headache in industrial sourcing these days.
Yeah, lead times are described as dynamic. Unpredictable, really. They depend heavily on the manufacturer's production schedule and more, on raw material availability. Lithium, chips, you name it. The sources are very clear. Lead times can change, sometimes after you've placed the order. The supplier only commits to notifying you if there's a delay. So procurement teams absolutely have to build buffer time into project schedules.
Right. Okay, ordering and payment, they're strict on security, no phone orders.
Correct. For security, no orders over the phone. Everything has to be finalized either online through their system or via email with an official purchase order, a PO.
And payment options, there are limits there too.
Yes. Wire transfers are fine. Major credit cards are accepted. But, and this is a big one, only up to $5,000. International clients, they often just require wire transfers, period.
That $5,000 credit card limit, that's a really practical detail. Why do you think they enforce that specific threshold in B2B?
It's pretty standard risk management for high-value industrial stuff. Capping card payments at $5K pushes larger deals towards wires or POs. That cuts down their risk of chargebacks, and it also lowers their processing fees quite a bit on transactions that could easily run into tens of thousands. Helps them maintain margins on specialized gear.
Makes sense. Okay, one last crucial point from the sources. Order accuracy.
Yes, they really stress this. Customers must provide the correct OEM part number, or original equipment manufacturer part number, to guarantee compatibility. Because the supplier might offer both the official OEM part and sometimes high-quality aftermarket alternatives. The product page specifies which is which, but you, the buyer, have to double-check you're ordering exactly what your system needs. No room for error there.
Okay, so let's try and wrap this up. What are the key takeaways from this deep dive?
Well, technically, the Kraken Charging Hub is clearly a sophisticated piece of kit. High capacity, highly efficient. That true sine wave output, low THD, the configurable charging, the solar and Modbus integration, it all points to a system built for serious, continuous industrial work. The kind of work standard vehicle electrics just aren't designed for. It's an intelligent solution to a brute force power problem.
And that technical capability goes hand in hand with a very structured, business-focused procurement process. Understanding those logistical rules, the $2,500 international freight trigger, the $5,000 card limit, the 30-day, quote, life that's just as vital for success as knowing it puts out 3,000 watts, the tech specs and the buying process are intertwined.
Exactly. Which leaves us with a final thought, something for you, the listener, to maybe chew on next time you're signing off on a big PO for critical gear. Given how much industrial procurement now depends on volatile things like manufacturer schedules and raw material supplies, things totally outside your control, you have to ask, is the reliability and transparency of the supply chain itself becoming more critical specification for these heavy-duty systems than, say, the peak power output listed on the datasheet? Where does your biggest risk actually lie now?